Hello, welcome to 11.3. Today we're going to talk about some uses and misuses of significance tests. Now, choosing a significance level. Now, there's not a sharp distinction between a p-value of 0.51 and 0.49. We should look at the p-values more than just whether we accept or we reject or fail to reject the null hypothesis. Because if a value is 0.51, a p-value, will fail to reject, and at 0.49 we will reject the null hypothesis. But that's not the full story. The full story can be seen in the actual p-value. Also, for practical importance, let's take a look at this example. If a study shows applying an antibacterial cream would decrease the amount of time that it would take for the wound to heal. The mean time was 7.6 days with a standard deviation of 1.4. A group of 25 volunteers used the formula and found that the mean healing time was 7.1 days, as a significance at a 0.05 level. Well, let's forget the parameter. I guess we need the null hypothesis. Let's do the null hypothesis. The mean is 7.6. The alternative hypothesis, the mean is going to be less than 7.6. Let's not worry about the conditions right now. Let's just worry about the calculations to see if this is significant. So for the calculations, we want our z-score to be 7.1 minus our null mean of 7.6 divided by 1.4 over the square root of 25. So this would be negative 0.5 on top. 1.4 over the square root of 25 is 0.28. So negative 0.5 over 0.28 gives us negative 1.785. So our p-value, probably our z-value is less than negative 1.785, is 0.037. So is this significant at the 0.05 level? Yes, it is significant. Does it matter? How practically important is this? Even though this is significant statistically, would you go out and buy antibacterial cream and put it on your wound for 7 days for only a half of a day improvement over nothing? I think most people would see that as being a waste of time and money. So just because it's statistically significant that it's less than 7.6 doesn't mean that it's all that important. It is always important to analyze the data. Running tests without looking at graphs or checking out for outliers can also lead to inappropriate conclusions. So you always want to look at the data, see what the information is. If a test fails to reject the null hypothesis, it doesn't mean that the alternative hypothesis is wrong. It doesn't mean that it's right. All we can say is whether we reject or fail to reject the null. Look out for multiple studies. A researcher looked at 30 different types of cancer and cell phone usage. She did significance tests on 30 different types of cancer, and one of them didn't pass at the 0.05 level. What does this mean about cell phones and that type of cancer? How many would you expect to pass? So 5% of the time, you're going to get a study that doesn't pass. So 5%, if you multiply that by 30, 0.05 times 30, if you do 30 studies, you would expect 1.5 of them to fall outside the 0.05 level. That's just what we expect. So just because one study shows that something proves higher levels of cancer, that doesn't mean we can go directly and say that causes it, because 5% of the time it's just going to end up in that location. You have to do many studies in order to find out a cause-effect relationship. All right, this was a short lesson. You have 4 problems to do. Good luck.